Hello, my name is Konsigli. I'm working for mobile device at Samsung Research. In this session, I'm going to present the LightSys to accelerate the integration speed of software. Here is the outline. In the past, most of the embedded devices just required simple software. Then, the connectivity of embedded devices has gradually evolved from a smart device based on software platform to IoT and edge devices. Also, the size and the complexity of the existing software platform image has drastically increased. The quick introduction of many code changes significantly increased the workload on the build and integration infrastructure. It may incur an extended delay over source code integration. We have analyzed the build process of 6 large open source software packages. These packages account for more than 50% of the total build workload of a software platform such as Tizen. The figure shows the latency breakdown of the building software in the typical desktop during a CI build test. From our analysis, the compilation consumed more than 60% of the time. This page shows the code review culture of developers in the industry. 342 experienced developers of our company participated in the survey research of the code review culture. Question 1 implies that most developers use version control system, despite the logic that may be neglected for software in the embedded device industry. Surprisingly, the 112 developers did not use the PR process for their development project, as shown in Question 2. As shown in Question 4 and Question 5, the 230 developers did not actively use a code review system such as the GitHub PR. This page shows the strong point and weak point between conventional systems and our approach. Jenkins focused on the high-end server resource. Travis CI and AWS Code Builder are not open source. Our approach supports a lightweight and portable code review system. Moreover, the existing system does not provide plug-in design and lightweight operation structure. This page shows the design principles of our system. The conventional systems are heavy and slow because their design structure is established to support larger functionalities. However, LightSys is very lightweight and faster because our design structure focuses on the fast code inspection and effective resource management. The existing approaches have focused on the infrastructure over the continuous integration. Reviewers often consume larger time for trivial parts such as code format and coding style, defect, and bugs. Our study points out that we have to provide the appropriate techniques in order to fix the delay of source code integration due to incorrect code patches. So we propose the lightweight and modular continuous integration system. Our system consists of a core engine and plug-in modules. In case of a core engine, it consists of 4 major components like webhook handler, inspector, modulator, and package generator. Plug-in module is responsible for enabling and disabling the required modules according to requirement of a GitHub repository. This page shows how a package generator executes a scheduling of the submitted commits. At first, developers submit their code commits with a pull request in case of github.com. Our pull request scheduler manages a lifespan and a scheduling priority over pull requester with a long queue and out of a PR killer. After a developer submits a PR, he often resubmits the same PR such as PR231 after fixing the commit due to the newly discovered defect. The PR killers minimize a server overload due to duplicated PR submission. The PR scheduler provides the developers with a larger merit compared to the conventional systems. For example, we guarantee that PR can be proceeded in time without an OOM situation thanks to PR scheduler. As a result, we have reviewers in order that they can concentrate on the meaningful and productive code review to improve software quality. In order to control merge request of source code without OOM situation, the PR scheduler uses two queues, such as wait queue and a long queue. First, the wait queue manages execution sequence of the created PR task based before. Next, the long queue contains priority values for each merge request, which will be used by PR scheduler when the job is successfully finished. The first request jobs waiting in the waiting queue are moved to the long queue in sequence. This figure shows how the modulator of our proposed system supports or customized plugin modules for source code repositories that have a different goal, which can easily enable or disable custom modules with well-defined two APIs, such as comment and report API. Here is a taskbed to evaluate our LightSys implementation. We established taskbed with AWS instance, Ubuntu 18.4, Linux kernel 4.4, three repositories such as Linux, TransFlow, Puppet2. Figure A illustrates the amount of PRs, PR frequency, and the number of PR executed with the same number on incoming PR. Figure B showed the CPU resource is inefficiently wasted due to the absence of PR killer and inspector. LightSys has reduced the CPU overhead by over 40% by removing duplicated or unnecessary tasks. This page shows that the memory consumption is significantly reduced with the proposed system compared to the conventional systems. In case of Jenkins, it has a Java-based VM system architecture to focus on server-based scalable software architecture. The Java virtual machine-based execution structure drastically increases memory usage. This picture shows our evaluation result whether the proposed system enables PRs to be normally performed without OOM status. This table shows the 10 processes that are most likely to be killed in the descending order in the Jenkins system. As expected, our proposed system does not have any OOM situation thanks to the PR scheduler and PR killer. This page compares the execution latency of the CI modules when we increase incoming PRs with the 20 plugin modules. From our analysis, the conventional systems generate additional build cost because they compile source code with a Docker container that consists of AUFS file system, process namespace, and C group. So far, in the summary, LightSys makes three major contributions. First, a lightweight and efficient code review automation system that lowers the operating cost and accelerates the code inspection process. Second, a set of code inspection modules allows reviewers to focus on more critical aspects. Last, a plugin structure that is extensible and configurable with the concept of the plugin store. Thank you for listening.
Hello everyone, and I hope you enjoyed this first paper in the session about code review automation. Let me quickly introduce myself. I am Antonia Bertolino. I am the chair of this blended session in which we have a very well combined set of 3 papers that I think complement, you will see they complement very well each other. I am here live on the stage with the 2 authors of the paper, Lim, that you listened in the presentation, and Ham, and we are ready for your question. And as I do not see still question, I take advantage of my position to make you, because I have several questions about your work. And the first question was about this check that you introduce in your tool LightSys. Maybe I was not careful in listening, but I did not really understand from how did you define these checks that you do? It is based on experience or on suggestion from developer? How did you decide which checks to do?
Yeah, in case of CI task in the LightSys papers, most of the CI task can be defined by the developers and users easily, because the LightSys support the extensible and modular the modularity facilities, and on the configurable and or the system generated package. Yeah, the LightSys include also the package manager. So it means that the most of developer can easily enable or disable the packaging process for the larger the software platform like Ubuntu, Tizen, Android, and Yocto.
Very nice.
Okay. Actually, the authors of this paper were the users of this CI system. We did not intend to create another CI system at the first time, and we just started using other CI system, including like a Jenkins or Circle CI. And then we felt the problem and we started writing our own in-house CI system for our software packages. So the CI tasks are defined by the users. So the users or the developers of general software packages have decided that we need some features, then we have just implemented the features into this LightSys CI system.
And essentially there is another catch now.
Yes. So this was more or less the same question that Francisco Gortazar asked in the chat. I think you answered this question. And now we have another question by Eric. If you considered that the review activity can be prioritized based on the cost and benefit, given the limitation in resource constraints. Who want to go first?
Yeah, good questions. Considering the priorities review activity is out of scope in our papers, because our paper focus on the acceleration of the code reviews by avoiding the larger trivial reviews from the reviewers. And on their cost benefit, our paper concentrate on reducing the system workload of the server, because as we all know, most of the build process require the larger the costs. Actually, for example, when developers submit the larger PVRs, as we all know, the review system have to consume the larger the hardware facility like CPU, memory, and disk.
I see. So Eric sent okay, and also I know that the next paper in the session will actually focus on prioritization. So this could be also useful to continue the discussion on this topic. Are there other questions from the audience? Let's wait if we see more questions. Maybe meanwhile you could comment a little bit about what are future activity that you are doing on this tool. What is the next features that you are adding in LightSys?
We are planning to consider the distributed environment because the LightSys paper focus on the reducing the system load of the delivery system. So as we announced, most of the facilities are based on the distributed environment. We can think about the Docker and the Kubernetes. So we want to the study on the distributed environment to encourage and the accelerate the larger the build cost and the larger review activities.
Okay, nice. So plans for ICSI 2022 maybe.
Actually, Config is disseminating this LightSys system to the all the other software development teams in Samsung. So I guess
Nice.
he really needs that feature.
That would be, yes, that would be really a good feedback and will certainly give you a lot of many other ideas for development. Good. Yeah, you are in a good position for having a practitioner using your tool. Sometimes for us, academic researcher is more difficult.
Right. Yeah. We have tens of thousands of developers here, right?
Wow. Okay. Oh. Okay. We have a link in the chat for the code. Thanks. Thanks, Sam. Okay. So maybe if there are not other questions, we could thank the authors. I applaud for all the audience. And yes, and also there is the discussion room if someone of the audience want to make a more specific question and discussion with the authors. Okay, we have more or less 1 minute left until the next video starts. So I thanks the author and the audience for the interesting question. And I go to the next backstage to prepare. Okay, thank you. Thank you.
Thank you so much.
Thank you. See you in a minute in the other paper. Okay, bye.
Thank you.
So how would I do now? Do I have to leave this room now? Okay.